Okay, well, welcome thrill seekers to the tour de force on anticoagulant poisons, which I'm asked to talk to you about. So I've saw a little bit of Teal's presentation before and could see that you're already talking about rabbits and how much of a problem they still are. I could see that you've got some concerns about whether the calicivirus is able to make a big enough difference over time, and that you're looking for other options that might help keep your rabbit numbers suppressed. So I'm here to help, and let's see how we go. So we're a bit behind schedule, so I'll go fairly fast, but I am known for giving seminars that have this kind of effect on people, and so we don't want that to happen to you guys. By way of introduction, I run a company called Animal Control Technologies. Started off as a sheep reproductive biologist in the Department of Agriculture in a research field, and did some work on immunobiology of pregnancy, and then developed melatonin treatments for sheep, but then got into pest control because the foxes were eating the lambs that I created. And then from foxes, I got into rabbits, plague mice, rats, cane toads, and feral pigs. But along the way, I actually wrote the registration for the rabbit calicivirus over here. We developed some ant baits for invasive ant species, a toad trap, and most recently the sodium nitrite hog-on bait for feral pigs. So I've got a fairly broad background. But we're here to talk about rabbits today. And in my opinion, and I'm sure Teal will be happy to hear me say this, rabbits still remain perhaps the most serious pest risk to Australia's landscape and agricultural industries. At the moment, we have a temporary relief via Myxoma and RCV. And Teal was very correct when she said that Myxoma posed issues for humaneness, and it would never be allowed to be released now, and wasn't released in New Zealand for just that reason. But rabbit calicivirus has mutated, just as COVID virus has mutated to form the Delta strain. RHDV, or rabbit calicivirus, has mutated to form RHDV2, which tends to be now the dominant strain. It emerged in 2010 in France, and it's very hard to get these new Korean strains to release and dominate over the wildly circulating strains. So very bluntly, we still need all the techniques we've got for rabbits. And you'll love this as well, Teal, I hope, because this is my very rough plot of what rabbits do in life. And the little orange line at the bottom of the screen is rabbits going up and down. It's a completely made up diagram, so don't try to read too much into it. But here's what I think we do as a society and as land care groups, whatever, and governments. We watch the rabbits build up. Then we apply for a grant, we get some money, we apply a program, we drive the rabbit numbers down, the money runs out, there's still a few rabbits left, the rabbits breed up again, we have a plague if conditions are good, we worry about it, we throw some measures at it, we get them down, then they build up while we're thinking they're under control, we get another grant, and so on and so on. And I'm sure all of you will agree, if we were successful, the orange line should hit the ground and stay there if we really got rid of them. And any program that you do should be aimed at really trying to get them. And I heard Teal say very correctly that the time to hit rabbits is when rabbit numbers are low, not when they're high. Because if you hit the numbers when they're low, you will get rid of them and you won't have the peak. It's more expensive per rabbit to hit them when they're low, but it's the best bang for your buck. So I think you guys know more about rabbit problems than probably I do, but they obviously eat all the available grass. They help cause displacement and get weed growth on the bare ground and so on. They create erosion problems, so they reduce the carrying capacity for both native wildlife and stock, sheep and so on. And most importantly, I think as well, they inhibit natural vegetation or planted vegetation regrowth and recruitment. I think you know all these things already. I used to have a director in my organisation who was a bit of a philosopher, and we actually had a mouse bait factory in a paddock in a very nice part of Victoria, similar to this country in the picture. And I admired one day while we were taking a tea break of how beautiful the scene before us was. I said, we might have a terrible mouse bait factory, but the place we've got it is in a beautiful paddock. And old Brian Coman, who was a well-known rabbit controller from the Lands Department days in Victoria, said, it's not a good seed. And I knew he was teasing me, and I said, well, I can see beautiful old red gum trees, sweeping plains. Everything looks perfect to me, Brian. What do you want about? And he just paused for a while and he said, there are no seedlings. And it hit me like a brick that my grandchildren would see these trees as old dead stumps, and there's just no regrowth. And in this case, it was because of grazing by farm animals, but as well as rabbits. So the whole issue of rabbits is that the damage they're doing is insidious. It's across generations, and we don't really always appreciate exactly the scale of the problem because it's happening so slowly, but isn't so insidious that we just don't react. So a very good take-home message here is that it is not good enough to achieve high levels of control in 3 out of 4 years, because if you're a seedling, you won't make it. So how much food does a rabbit eat? One rabbit will eat roughly of wet food, 100 grams of carrots, roughly 10% of its body weight per day. But dry food like oats, it'll eat about 40 grams. So over a year, one rabbit would eat 36 kilograms of carrots or 15 kilograms of oats. 100 rabbits would eat 3.65 tons of carrots and green grass or whatever, and 1.46 tons. That 100 rabbits isn't very many rabbits. This is a lot of feed that they are processing. So they really do a lot of damage. So in my opinion, and I've been quoted on this elsewhere, rabbits have the capacity to turn Australia into a desert all over if they're unchecked and by biocontrol or other actions. And the old Cyro photo there sort of shows what rabbits do. So we do have to throw everything we can at them. It's a little bit old-fashioned in some cases, but no single method will do the job by itself. So we have the biocontrols, which Teal has mentioned, myxomatosis and calicivirus, but I know of no biocontrol that's ever eradicated its host. So these are knockdown or reduction tools, not eradication tools, because the virus would eradicate itself if it eradicated its own host. So it just doesn't work that way. Plus we've got developing resistance and attenuation of both viruses. And we've got dominant strains now which may not be quite as lethal as the original strain V351, which I did the registration for years ago. We can try to fence rabbits out, but it's very expensive. Rabbits can tunnel under and trees fall off fences. And by and large, fencing is not a viable option unless you're just protecting the veggie patch or some small area. Of course, we can shoot them, but even counting rabbits is hard because they scatter very quickly when you come over the hill with a spotlight, and you come over the hill with a shotgun and they scatter even faster once you shoot the first through. So it's good fun, but it's not really getting on top of the whole population. And as Teal said very correctly, if you leave a few behind, you'll have a lot for next year because they breed up very fast. A good technique is Waroona fumigation, and we used to do that with a chemical called chloropicrin. That's now phased out. It was a very dangerous chemical. There were a couple of people killed or nearly killed when using it. It's a very nasty gas that irritates the lungs. Not terribly humane either for killing the rabbits, but it did work. It was very toxic and it killed rabbits. But we can still use, I believe, aluminium phosphide tablets, which degrade fairly quickly to produce phosphine gas, and you roll them in some wet tissue paper, or some people even stick them inside an orange to get a little bit of acid to accelerate the release, roll them down their rabbit warrens, and then seal the warren off, and the phosphine gas kills the rabbit. So not an impossible technique, not too commonly used, but still available. Importantly, these little fellas here, bulldozers and rippers, are very important in any control program, because if you're in a country and I believe you guys probably are in country where ripping will work well. Some parts of Victoria, we've got granite outcrops, and bulldozers don't like granite outcrops if you're trying to put your rippers in. I have a bulldozer, so I know about these things, but warren and harbour destruction is an important part of an integrated program. In West Australia, you've used 1080 baiting with your old one-shot oats that used to be made by the Agriculture Protection Board, and that was heavily dosed oats that were mixed with normal oats, so eventually the rabbit encountered a toxic one, and there was enough poison in it to kill the rabbit. And that did give good control. It's cheap and effective, but there's a general swing at the moment nationally away from 1080, mainly because people are concerned about secondary poisoning of farm dogs or working dogs or pets. Harder and harder to get approvals and so on. We make 1080 oat bait for rabbit control, and we provide 1080 concentrates to enable you to make your own carrots if you want. But it's an area which is under pressure, but certainly still very effective. Trapping for rabbits is really not a great option because you need a trap for every warren pretty well. Maybe if you're collecting rabbits like they did in the 50s, you can herd them into a yard that's got a corner where you can beat them to death with a club, which is what they used to do. But I call that a big sort of pen trap. But in my opinion, you can trap rabbits, but you'll be there for a long time trying to get rid of a rabbit population. So today I want to talk to you particularly, because Teal asked me to, about rabate or Pindone baiting, because there's a bit of a lack of knowledge about anticoagulants, and I'll try to fill you in with some sort of very technical stuff from now on. So if you want to put your sunglasses on for the technical stuff, here it comes. So what is an anticoagulant poison? It's really something that interferes with blood clotting, and there are two types. There are direct inhibitors, and you will have heard of some of these. If you get a blood pack from the blood bank, to stop that blood clotting in the blood pack, they add citrate to the blood, and that actually soaks up the calcium ions. Calcium ions are necessary for clotting reactions, so that stops those blood packs from clotting. Or they can add heparin, and some snake venoms have anticoagulants. So these are things that directly stop blood from clotting. But in a live animal, we have a whole complex process of indirect inhibitors. Well, sorry, my apologies. In animals, we have a clotting process which is very complicated, and the indirect inhibitors of that process are the anticoagulant poisons, which we'll talk about. So now, to check if you're all listening, however many of you there are, because I can't see you, would you all like to just clap your hands really hard once, please? On the count of three. 1, 2, 3, clap. Oh, gosh, there must be a lot of you. That was noisy. Great. You've just all damaged the blood vessels in your hands, and your clotting system is now swinging into action to plug the leak. So what you just did to your hand is shown on the right-hand side of this slide, if you can see it. You've got some red cells leaking out of your capillaries. Your platelets are rushing to the hole that you just created by squashing some capillaries when you banged your hands together. And the whole process is starting to plug the leak that you don't even know exists. What is also happening is a whole series of enzymes have been activated in your hands to control the perfect sealing off of the damaged blood vessels. Now, you don't need to remember these. There's no exam at the end of the day, but they were investigated for a period of nearly 100 years. They are still being discovered even to this day, and the clotting system is a very complex process. The first one discovered about 100 years ago was fibrinogen. The next one was platelets, when they started looking in microscopes at blood and so on, and then so on, all these other chemicals, and I'll explain what they do in a moment. Unfortunately, they don't act in the system. Number one doesn't lead to number two, to number three, to number four. This is the order in which they were discovered over time. So it's a bit of a messy system when you say factor 7 activates factor 9, and you think, okay, well, factor 9 activates factor 7. They're in the wrong order. So when you do a complex picture of how this works, you end up with one of these diagrams, and that's a very accurate diagram of the clotting system, and I'm not going to spend time going through that because I've tried to simplify it, and I'm just hoping if the next slide shows up, can someone just tell me if you can see it all right on your screen? Okay, right, good. So we just clapped our hands and we had a blood trauma here. That caused this little arrow here, the yellow lines are arrows, and that caused platelet phospholipids to be released locally, and they then activated these enzymes here, which ultimately led to the activation of prothrombin accelerator, which activates prothrombin enzyme from an inactive form to form thrombin. Thrombin's a super powerful enzyme, which then acts on fibrinogen to turn it into fibrin. And you'll know fibrin because that's what clots are made from. So as a quick response to you clapping your hands, you started that reaction. But behind the scenes, there's a kind of a mop-up action, as best I understand it, where all these other blood factors, not in the number order, but they are a series of enzymes which go from an inactive state to an active state. And ultimately, they all turn on the same system and go through to cause fibrinogen to be turned into fibrin. Along the way with all these activations, a number of chemicals come into play because this is just chemistry at an enzyme level. And one of the things that happens to increase the activity of these enzymes and make them active is they accept a methyl group from a methyl donor. In this case, the methyl donor is vitamin K. So I've shown in 2 places here, but it actually has a role in up to 6 or 7 different places. But the 2 main ones are to provide activation of these 2 critical enzymes. So we've got enzymes being activated, clots being formed, but to activate some of the enzymes, we need methyl groups from vitamin K. Are you all with me, thrill seekers? That's the worst slide of the presentation. It gets easier from here. So vitamin K is essential for clotting processes. If you don't have vitamin K, you will bleed to death. So it's a very, very simple outcome and a very permanent one. So all animals, Mother Nature is very clever. Vitamin K can be absorbed from cabbages and spinach and I think broccoli and asparagus are some of the main vegetables that supply vitamin K. And you can get it from animal fats and things as well. So there's a number of sources, but we can't clap our hands together and rush and eat a bunch of asparagus to give ourselves enough vitamin K. So Mother Nature is very clever and gives us a large reserve of vitamin K ready to use whenever we need it. So you have some vitamin K and you've just used some of it to repair the blood vessels in your hands. But once the vitamin K has donated its methyl group to the enzyme to activate it, it becomes inactive vitamin K and it's useless. So Mother Nature's worked that out and Mother Nature sends that vitamin K back to the liver, and there's an enzyme in your liver which reactivates the vitamin K by putting the methyl group back on. So this is just straight chemistry. We have a chemical, it does some work for us, it exhausts itself by giving its methyl group away, and we send it back to be recycled. And that's normal, and it's normal in most, if not all mammals, I think, at least ones with blood, with our type of blood. So the enzyme in the liver, which allows vitamin K to be reused, is called epoxide reductase. There's no exam, you don't have to remember that. But that is the enzyme that we inhibit when we give anticoagulant poisons. So that's how they're working. And I'll explain in more detail. This is actually a diagram of vitamin K. It's got this long wiggly bit of lipid out the side, and it's got this fancy little structure here, which I've just shown a bit bigger here. And I want you to sort of remember that shape. Technically, this is a phenol ring. If any of you are chemists, and I can't remember what that one is, these are oxygens with double bonds. But that general shape you'll see again in a moment. So that's our little vitamin K. We've got it, it's fine. When it becomes inactive, it actually donates this methyl group to the enzymes that it's activating, and it goes through 2 regeneration enzymes to be recycled. And I've tried to show that here. This is the inactive cofactors in the clotting system, all these numbers, factor 2, factor 8, factor 7, factor 9, whatever. And they go from an inactive form to an active form because vitamin K activates them. Once the vitamin K1 has done that job, it's useless. So it goes back to the liver in an inactive form, and then it gets converted back into active vitamin K. The anticoagulants block this enzyme. Now that's important for you guys to understand because they don't, anticoagulant poisons, people think of poisons as something that destroys a tissue or rots your brain or causes your fingers to fall off. It does none of those things, it just blocks an enzyme. And enzymes don't have nerves or feelings, they're just chemicals in your liver. And if the vitamin K causes it not to work, the anticoagulant causes it not to work, your vitamin K will run out. And of course, it also means that the vitamin K inhibiting enzymes, if you block them, you run out of vitamin K, but you can solve the problem by giving some vitamin K. So if your dog gets poisoned by an anticoagulant, you can actually save it by just giving it some vitamin K. As long as it's got vitamin K, it won't bleed to death. So you can inject the vitamin K, but it is a little bit expensive. And as you'll see in a moment, for the modern rat poisons, especially this bogey one here, Bodifocum, you have to actually, it's very long acting, and so you have to give a long treatment with vitamin K. The vets love it because they can sell you lots of vitamin K at a big cost, but unfortunately, it's one of the problems of these new chemicals. So now we have chemicals which inhibit all this enzyme, and they fall into two groups. One group is called the coumarins, and there's a list of possible ones here, there's more. Coumarin was discovered because cattle in Wisconsin in America were eating grass that had a fungus on it that caused the cattle to bleed to death. And this was about now 70 years ago. The scientists at the Wisconsin University discovered that the chemical that was causing the problem was called coumarin. And they got the bright idea that if it's killing cattle, maybe they could use it to kill mice, but it didn't work very well. So then the chemists at Wisconsin University modified that chemical, and they called the modified chemical warfarin. And that's because the W is for Wisconsin Alumni Research Foundation coumarin. So that's how warfarin got its name, if anybody wants to know. But then the chemists in the 60s got smarter again and said, we can make warfarin more powerful by making it last longer. And so they added more things onto it. I've got pictures of these things in a moment. Likewise, another group of chemicals which blocks this same enzyme are the indoles, and the main one of those is Pindone. But like the coumarins, there are other versions of it, but I won't worry about that for now. So remember our vitamin K molecule from before. Here's that end of the vitamin K molecule, and that's being operated on by an enzyme to put the methyl group back on. Notice the very similar structure here of coumarin. So it's not a surprise to say that if you eat some coumarin, it might block the enzyme that's trying to look for vitamin K and recycle it. And I think that's what's going on. The coumarins are probably blocking the binding sites. So that's the simple coumarin structure. It's deceptively similar to one end of vitamin K. It blocks the enzyme. That's all it does. If that's our coumarin again here, if you add all this stuff onto the coumarin molecule, you make warfarin. If you add a slightly different version of that onto the thing, you make coumatetralyl, and so on. Warfarin then can be converted to bromadiolone, which is a common rodenticide for rodents, or coumatetralyl can be converted to Bodifocum and flucumefin. Don't need to remember the structures, but you will hear a lot about, I don't want to use anticoagulants because they kill wildlife. And if you were in New South Wales during the mouse plague this year, the New South Wales Ag Minister said, I'm going to napalm, and that was the word he used, napalm, all the mice in New South Wales by spreading bromadiolone bait all over the paddocks. There was an outrage globally about that because these chemicals last a long time in the mouse. When they kill mice very well, but the mice then are eaten by the crows or the eagles or the owls, and anything that eats the mouse gets a second-hand dose of this chemical, which has a long half-life. So it accumulates up the food chain, and therefore these chemicals are not used. They would kill rabbits, by the way, as well, but and they'll kill anybody. But the problem is you don't use them on a large scale in the broad open land because of that food chain accumulation. So what I want to sort of drive home here is that not all of these chemicals are the same. They have very different risks depending on their structure. So the indoles, again, have a similar looking thing at this end. And this one is Pindone. There are derivatives of Pindone as well. I won't worry about them, but this is the one that we use for rabbit control. And the odd thing about Pindone is that it's very toxic for rabbits, but not toxic enough to be used as a rodenticide. So these things here were synthesized to try to make a rodenticide out of it. And we're actually using difascinone with the US government at the moment to control mongoose populations in Hawaii, and it's working. But Pindone wouldn't work for those animals and doesn't even kill rats and mice. So its toxicity for a lot of species is very low, but for rabbits it's quite high. Once the rabbit eats the Pindone, if the rabbit dies, the Pindone level has no way of being degraded, so it just sort of sits there, but it's very low. But in the live rabbit, once you dose with the Pindone, over time, the level of Pindone in the rabbit liver, which is where the enzyme is that it's blocking, decreases. And I don't know if you can see it clearly on your slide, but if we say it starts here at 250 and falls down to sort of 125 here, that interval is about 4.5 days. So we've measured this, and that's the half-life of Pindone in a live rabbit. Now, the rabbit doesn't die immediately because all we've done at the start is switched off an enzyme, but you've still got vitamin K on board, so you're happy for a while. So what I'm trying to point out here is as the rabbit dies, it's also degrading its own Pindone and getting rid of it. And that leads to the next point. Okay, so here stylized is our dose of Pindone. Here's our Pindone degrading over 4.5 days to half, but it lasts longer than that. But while it's in the system at a reasonable level, the enzyme in the liver is being switched off by the presence of Pindone. So the animal is still using vitamin K, so the vitamin K levels fall. And these are stylized, hand-drawn diagrams. But what's going on here is the animal is behaving normally, but behind the scenes, vitamin K is being used up. But if it has enough to survive for 5 or 6 or 7 days, and the poison is metabolized away, the enzyme can switch back on, the animal recovers, no harm done. So if you don't go below a danger level, you can tolerate a little dose. So a non-target animal eating some Pindone, for example, a little dose, like a bird eating a dead rabbit or something, it wouldn't get to a danger zone because it would fly off and eat somewhere else the next day or whatever. So the risks are quite low. So how do we kill rabbits with this stuff? Well, it's very important to think about this. What we worked out over, this is a long time ago, we did this research, is that it's much easier to kill the rabbit if you give them several exposures to Pindone and you actually use less poison. In fact, we halved the amount of poison that was needed by changing the interval between the doses. So what's going on here is we give a dose, the chemical's absorbed, goes to the liver, blocks the enzyme, and the rabbit then tries to get rid of it, metabolizes it. But before the animal can recover, we offer another dose and hold it down again, and then another dose, ideally. So what happens behind the scenes to vitamin K is it starts to fall, but it can't recover because we topped up the poison, so it just keeps falling and falling and falling until the clotting system fails. But we know that any 2 of those 3 doses will kill a rabbit most of the time. So if it wanders along and eats the first dose and the second dose, it will die. If it eats the first dose, misses the second dose and eats the third dose, it'll die, and so on. But we offer 3 doses, and you can offer more if you want, just to maximize the chance that all of the rabbits in the group get a dose. Okay. So what is the toxicity of Pindone to the rabbits? Well, you can kill a rabbit with 1 big dose of Pindone because it goes up so high that it takes more than a week for all of the Pindone. And this is called the acute toxicity, easier to measure than the chronic toxicity. So this is a way of comparing animals. But a rabbit has what's called an LD50 dose of 13 milligrams of Pindone per kilogram of rabbit. A rabbit weighs roughly a kilogram, and so they would need, roughly speaking, 13 milligrams, and it's not a precise science, 13, 14, 12, near enough. But at our current dosing on, say, an oat bait, the rabbit would need to eat, to get in one dose enough to kill it, 260 grams of oats, which is quite a bit. Probably wouldn't eat that much because it's more than a meal of oats. A sheep, on the same comparative basis, we don't know the exact LD50, but the sheep weighs 40 kilograms. So it would need to eat nearly 3,000 milligrams of poison, which means it would have to eat 59 kilograms of the rabbit bait to get a lethal dose in one hit. Pigs are a lot more susceptible than many other animals, so a bit less, even though a pig might weigh 100 kilograms. But a rat has to eat pretty much its whole body weight to get a lethal dose, and they just don't do that. And possums, likewise, they have to eat a lot. So you don't easily kill any animal with one dose of Pindone, but if you're going to kill one, the one that's most susceptible is the rabbit. Okay. So, a quick summary. Features of Pindone: it's a first generation, so short-acting, rapidly degraded anticoagulant, but it is pretty toxic for rabbits. It's quickly metabolized in the rabbit, so by the time the rabbit dies, a lot of the Pindone has been degraded in the rabbit, but not enough to let the enzyme switch back on. So there's a low risk to non-targets, and I've been trading and developing whatever these products for 25, 30 years. We're yet to have a dog death confirmed from Pindone programs. The only real risk is if a non-target animal eats the bait itself. There's very little risk from the rabbit, secondary poisoning, quite different from 1080. We have no evidence yet for reversion of rabbits to Pindone, and we know even if a non-target was to get a dose, it doesn't act immediately because the enzyme has to be switched off for several days. So if you had a problem, you can administer vitamin K as an antidote. Seldom needed though, however. I won't worry about that. I'm just going to erase some folklore, but I'll skip over. So coming to rabbit control, because that's what you guys are really interested in. Rabbits breed better during the cooler months, but they can breed any time of year. They can mate once per month. So they have what's called a very short lactational anestrus. This is quite remarkable. Most animals, after they give birth, the action of oxytocin on their ovarian function means that they don't ovulate and can't remate or get pregnant again until that suppression is released. But rabbits have what's called a very short postpartum anestrus. In other words, while they're lactating on one litter of kittens, they're getting pregnant again in utero with the next one. So it's like a continuous production process. Their gestation period is about a month, and they can generate 4 to 6 young rabbits per litter. So in theory, perfect world, you could have one female rabbit generate 35 new rabbits in a season. I doubt that really happens to that level. It's a bit of a theoretical figure because other things limit. That rabbit would be working pretty hard, probably wouldn't survive, might run out of food, whatever. So anyway, so they're breeding, they have been breeding, and they'll continue to breed, but now feed is getting short. We're coming into summer, so there are options for green feed, except for this terrible rain you've all just had, and we're the same in the east, by the way. It's actually not so easy to bait rabbits at the moment because there's so much alternative feed. And I think Teal said that about your calicivirus pellets. They're just not eating them because they're happy eating the grass. And that is a bit of a problem. But nevertheless, in general terms, summertime from now onwards is the ideal time to knock rabbit populations down with poison bait. So the Pindone bait that we provide was the first sort of commercial product out there, and it's called Rabbait. There are some copy products nowadays, but I'd like to tell you ours is better, and we do make it properly. It's available in 2.5, 5 and 10 kilogram pails. We used to also provide a kit with some gamma irradiated free feed oats or pre-feed oats to train the rabbits onto the trail, but frankly they were never very popular and we've discontinued them. It is an S6 poison, which means that you don't need special permits or licenses to use the product. In Victoria, they have put some state control of use on the product to make it a bit more like 1080, which is actually a mistake. But I'm pretty sure in Western Australia, you won't have any restrictions. There's no obligation to notify neighbours, but we recommend you do because it's actually better to work with neighbours to control rabbits over a big area. So most people don't mind as long as you let them know. We also make a concentrate, which is liquid pindone in a solution with dye, and that is only made available to licensed contractors or government agencies. So if you're just a member of the public or a landholder, you can't buy that directly from us or from a merchant. But the normal bait you can buy from a merchant, or we'll make it available directly from we've got a little facility at Bunbury. Couple of safety points. The pindone on our oat bait is actually on the outside of the oat, on the husk, which is also dyed green. And the reason we do that is green is not a preferred food colour for birds. Birds search for ripe food, which is usually red or yellow or orange coloured. And people have done preference studies on birds, believe it or not, and their least preferred colours are blue, green, black and brown. So our mouse bait is black, pindone is green, and our 1080 baits are blue. So it does reduce bird uptake. It doesn't prevent it, but if you do have a parrot eating the bait, they actually eat the kernel and throw the husk away. So they throw 90% or more of the poison away and don't eat it. As I mentioned before, there's no known aversion. It's metabolized in the rabbit and it can be sold through merchants. So getting to the end here, Till. So estimating rabbit numbers, not easy. If you had, for example, 25 rabbits, we would say put out about 3/4 of a kilogram of bait. If you have 100 rabbits, 4 times as many, 4 times 0.75 is 3 kilograms. In other words, this is oat bait, about 30 grams of bait per rabbit on each feeding occasion. Now, some of that will be wasted because the rabbit just doesn't encounter or doesn't follow the trail that you've put out, or they're feeding somewhere else. So it's a loose science, but the main point is that this is actually not much bait. So you don't need to use a lot of it, and a single pail goes a long way. If you're doing a much bigger program, you try to count the number of rabbits or estimate the number of rabbits per kilometre of spotlighting that you do. If you have a high number of rabbits, which might be more than 50 per kilometre, and you can have 200 per kilometre, you would then work out roughly with oats, you'd put maybe 10 or 15 kilograms of product per kilometre of trail. For carrots, you put out more, but as I mentioned before, rabbits eat more carrots than they eat of oats. And so don't be misled that you put oats out and you don't see much being eaten. That's because they don't need to eat much. But to balance that, when you're making carrot baits, you actually put less poison on. It's actually half. And ballpark, it's approximately the same amount of poison being given either way. It's just you have a higher dose product for oats than for carrots. So it's a loose science. And what you tend to do with this, because we're feeding it out on 2 or 3 occasions, and even more if you want, is you keep an eye on how much is being eaten. And if it's all being eaten, you think, oh, I didn't put enough out. But if a lot of it's not being eaten, or some sections just you don't have any rabbits visiting all of a sudden, then you don't need to top that up and put more out. So where do you put it? Well, I can tell you, because Victorians are pretty stupid, so many people in Victoria put the bait down the rabbit hole, thinking that that's where the rabbit is going to eat it. But in fact, rabbits live in holes. So if you want to give them a pillow, put that in the hole because that'll make them a nice bed. But if you want to feed them, put the bait where the rabbits are feeding. So here's a stylised grassy patch where the rabbits are feeding, and I've shown an imperfect bait trail that zooms around through the feeding area. And the idea is the rabbit from this hole or this hole will wander around here to get some food and encounter the bait trail, check it out, start eating the bait, and then they like it, it's flavoured up, so they will travel along the trail and eat enough to kill them. So when we're putting these trails out, this is a very flash stylised trench, way too deep and way too much work to do that. All you need to do is scrape a mattock or a hole on the ground to create a little bit of disturbed soil, because rabbits for some reason like to investigate disturbed soil, and then you literally sprinkle the oats along that trail. So when I say sprinkle, that's a pretty thick trail of oats. So you don't need to put whacking great heaps of them out, because you'd just be wasting the bait. It's actually quite effective at quite low amounts, and 30 grams per rabbit is not very much. So I just want to make that point, I hope. And if you're doing big programs, there are commercial bait laying machines, and this one, if you can see it, has got a little disc plough at the front. So it scrapes a very shallow furrow. As the machine drives along, the drum rotates and you've got little adjustable slots, and it puts out little dollops of bait along the trail. So in big programs, I'm sure you guys have got these from your old agriculture protection board. So if you want to pre-train the rabbits to eat oats, you can, but with that's normal practice with 1080. But if you want to just go straight to the poison bait with Pindone, that's okay. You kind of use your first feed as a bit of a sighter, adjust your dosing for the second poison feed and third and maybe a fourth if you want. But if you did the pre-feeds, you put out your poison feed when you know your rabbits are on the trail and eating your bait, and nothing will happen for the first week or few days, 5 days, 7 days. Very few rabbits die within the first week. Why? Because they've got vitamin K reserves, and you've got to wait for those reserves to run out. But after a while, the rabbits start to have problems with the clotting, and the death rate rises until all the rabbits are gone. So some rabbits won't die until out to something like 20 days, 3 weeks from when you start the program. Most will die between day 10 and day 15, but initially it's different to 1080 where the rabbit's dead in a couple of hours. So don't be surprised if you put it out and then you say, I don't think it's working. If the rabbits are eating it, it works. It just has a delayed effect, okay? So simple point, working with your neighbours is obviously good. You get better control over a wider area, and it's a good neighbourly thing to do in any group. And by way of winding up, we have good technical information on our website. So that's our website here, www.animalcontrol. And Teal, I can easily either send you or you can download the booklet that's got all that I've just talked about. I've talked in a bit more detail, but that's available free of charge if you want it for your land care group and so on. So, yeah. So I think, thank you for listening, and thank you for the opportunity to present. I'm happy to have any questions, but I want to give you a message of hope. I think we can beat the rabbit, but ignoring the rabbit is a big mistake. Thank you very much for listening. Well, you've just really got to go out at night with a torch or a spotlight and have a look around, see where the rabbits are feeding. They'll generally be feeding on any nice short grass in mown lawns or pasture that's been grazed. By the way, I should have mentioned, Pindone does also work on hares, but hares are very much solitary feeders, and where you see them one night isn't where they are the next night. They wander all over the place. So if you could get them to stay in one place, you could bait them with Pindone oats or carrots. But in general, hares are much more difficult to control than rabbits. So the poison works on them, but they don't feed in the same place often enough to set them up for a fall. But for the rabbits, just go out with a torch. Rabbits are what they call precuspular. They're mostly active at dusk and dawn. So just after sunset is not a bad time to go out with a light and just see what's around. And that's where you put your bait, because that's where they're feeding. Point on the bandicoot is that's always a concern, because bandicoots can eat, I think bandicoots can eat carrots, but not oats. And I must say, the guy who taught me the lesson about trees and seedling regeneration, he and I did a program at a place called Jellybrand Hill when I first started getting involved in rabbits, because Brian was the expert, not me. And we were able to, it was an enclosure where they were trying to rebreed the eastern barred bandicoot here in Victoria, which was thought extinct, and then they discovered them, set up an enclosure and bred them up in captivity in a large area near the airport here in Melbourne. But then rabbits got in, and we had roughly 50-50 rabbits and bandicoots, and we were able to kill all the rabbits and none of the bandicoots with Pindone. And unfortunately, I don't want to be quoted because I can't remember which way around we did it. It was about 20 years ago. And I know that it was either oats or carrots which we were able to target the rabbits without affecting the bandicoots at all. So there is a hope even there, Teal, that you can do safe rabbit control in the presence of bandicoots, but you have to check your bait. And yes, you can. Rabbits are like foxes a bit. They don't actually like going into cages and any new structures out there, but if you pre-feed, you can pre-feed them with just ordinary oats or carrots and put that underneath a bit of reinforcing mesh that can be propped up on a couple of bricks or something like that, so the rabbit can get underneath, but wallabies and those kind of animals can't so easily access. And that has proven effective. It's a bit fiddly to do, to be honest. If you can avoid having to do that, that's better. But there are ways to do it. But using a hopper like we do for our hog-on pig bait, I think rabbits probably not very much able to open a box or a hopper or move a clever lid or something like that. So they'll just find somewhere else to feed. So I don't think we can come up with a dispenser that would be target specific for a rabbit. But you can make it harder for other animals by just putting some large reinforcing mesh over your baited area. That's true. And with Pindone, we don't favour pre-feeding for a long time because, of course, you start training the birds to eat the oats or not carrots so much, but that has a downside as well. So we try to not train other animals to be there eating the bait. Yeah, the secondary poisoning risk is very low, not impossible, but generally secondary poisoning is demonstrated by taking an animal like an eagle and putting it in a cage, poisoning some rabbits or some mice with a chemical, then feeding them to the eagle as its only source of food. And eventually the eagle will fall off its perch for sure. It's really secondhand primary poisoning rather than true secondary poisoning. So birds don't feed in the same place all the time. They wander off and feed all over this place. So they don't tend to get significant enough top-up doses, and there's not enough residues in the rabbits to cause a problem. So we have not had any bird deaths, at least that are reported to me. Of course, it could have one that no one tells me about, but we've been doing this now for some 30 years. There's been no outcry, no major problem. The worst thing we've had, I think, is someone deliberately poisoned some wallabies by deliberately setting them up and feeding them large quantities of bait, but that's misuse. That's not a problem with the product. So touch wood, you never say never in this business, but the risks seem to be extraordinarily low. True, but in fact, I didn't mention it, but in fact, when the rabbits, they're normal really for about a week after the poisoning starts. Their enzyme's been switched off, but they don't know that, and so they behave normally. And so they come in and out of their burrows and feed, and that's why you can give them multiple doses over a period of a week or two. But actually on about the day before they die, I think they have some sort of clinical malaise because they're starting to lose blood internally. And so they tend to stay at home in their warrens, and most of them die underground, which is also good. Whereas with 1080 baiting, they kind of die while they're still eating the trail sometimes. So you find a lot more rabbits on the surface, and they can pose a secondary risk to dogs because of the high doses of 1080 we used. But with Pindone, it's actually a very much different. And in fact, the thing I have to explain to your members is they'll initially think it isn't working because they don't see anything happening, but the rabbits just quietly disappear. So I often get calls, someone would ring up a week into a program and say, "Oh, I tried your product and it didn't damn well work." And I say, just wait, ring me back next week. And sometimes they do, and they say, "Yeah, you're right, but they've just disappeared. I don't know where they went, but they're not there anymore." And I said, "Well, they're on the ground dead." So that's another way of reducing the risk to scavengers and so on, but it's low anyway. Even I worked out that a farm dog would need to eat 13 rabbits that had each eaten the maximum dose of poison bait to get an acute lethal dose. That's more rabbits than one dog can eat. So the risk is low. Look, just if it's a small program in a domestic situation, go along the trail and just kick a bit of dirt along the trail and the oats will sort of be buried. Get your garden hose and wet the oats. Pindone is water soluble, so you will actually soak it off the grain and reasonably quickly. It'll soak into the soil and be denatured. So there's no long-term contamination risk or anything like that. Certainly not the quantities that we're using here. But it is water soluble, so wetting, just washing it away is good enough. A lot of the early work on Pindone was actually done by Oliver and Wheeler, two research scientists at your Agriculture Protection Board at Forestfield. I know Oliver died many years ago. I'm not in touch with these guys. It was sort of almost before my time, but the original data on Pindone was actually done in Western Australia, so they were pioneers. They got the dosage strategy a bit wrong and said give 2 doses 2 days apart. And that perhaps gives me a little segue to say to you that if you put a dose out and you're coming up to say 3, 4, 5 days from the first dose and you're due to do another one, but it's raining, just wait another day. There's a fair bit of flexibility in the strategy. So if you stretched it out to 5 or 6 days between doses, that's still going to be fine. But generally speaking, it's not such a good idea to give a dose on day 1, day 2, and day 3, because that's just like one big dose. And that won't hold the enzyme off for long enough. So you're actually better to be a bit sloppy and do your repeat dosing at intervals that are on the longer side rather than the shorter side. Thanks very much for the opportunity to present.